today we have APU's academic leader from the School of Computing to speak to us as well. So hope you guys can take this advantage and ask any questions that you have. All right, and I will pass the time over to Ms. Miat from APU to introduce the speaker for today. Over to you, Ms. Miat.
All right, thank you, Leon. Thank you, Edumetry, for the opportunity. We are from Asia Pacific University, APU. My name is Miet. Together, we have our academic lead of a school from School of Computing, Mr. Naresh. So today, he's going to share about the topic of the domain of computer science and the potential job options. So, of course, if you have any questions like Leon mentioned, please leave your message in the chat box. On behalf, we will try to answer your questions as much as we can. Okay, so without further ado, let us welcome Mr. Naresh. Yeah. Yeah, over to you, Mr. Naresh. All right.
Thank you, Miat, Ms. Miat, and Mr. Leon. Hi, good afternoon, everybody. Can see and hear me, right?
Yeah.
Okay. So I see somebody responding. That's good. So please keep responding in the chat so that I can actually understand there's someone here. Okay. Otherwise, I feel like I'm talking to myself. Okay. All right. Let me introduce myself again. So my name is Naresh from School of Computing, APU. So I'm actually from the CIT department, which is short for Creative and Interactive Technologies. All right. And today I'm going to speak about computer science. What is computer science all about? And also job related options after completing computer science. And the more important question is computer science suitable for you? Okay, that's also important. Okay, let me just share my screen. Okay, this one. Okay, that's my friend, Mr. Robot there. Can you all see the screen?
Yep.
Okay. All right, first question, basic question. Don't know any of you know the answer or not. So what is computer science? I know don't look at the picture, it's very complicated. So what do you know about computer science? What is computer science? Or if I may translate to Malay, science computer. Everyone here understand BM, right? Any international participant here outside of Malaysia? So you can type your answers, maybe a short answer in your chats. Let me just look at it. Okay, I'm reading some answers. Anything related to IT, coding. Okay. Technology, programming. Well, I think most of the answers are correct. Okay, so let me play an introductory video which explains the concept of computer science. Okay, in a more graphical way, right? Okay, let me share again. Okay, please let me know if you can see and hear the video.
Is it playing? I think we're looking back at your slide.
Sorry?
We're still looking at your slides. The one on the what is computer science introduction slide.
Introducing Speechalo, the most natural sounding text.
The sound, but we can't see the window. Oh. Yeah, maybe
wait.
Share again. Yep.
Yeah, let me share again. Okay, share sound, share. Should be able to see. Okay.
Text-to-speech software on the market. Hey.
We built our brains. Originally, scientists built computers to solve arithmetic, but they turned out to be incredibly useful for many other things as well. running the entire internet, lifelike graphics, artificial brains, or simulating the universe. But amazingly, all of it boils down to just flipping zeros and ones. Computers have become smaller and more powerful at an incredible rate. There's more computing power in your cell phone than there was in the entire world in the mid-1960s. And the entire Apollo moon landing could have been run on a couple of Nintendos. Computer science is a subject that studies what computers can do. It's a diverse and overlapping field, but I'm going to split it into three parts: the fundamental theory of computer science, computer engineering, and applications. We'll start with the father of theoretical computer science, Alan Turing, who formalised the concept of a Turing machine, which is a simple description of a general-purpose computer. People came up with other designs for computing machines, but they're all equivalent to a Turing machine, which makes it the foundation of computer science. A Turing machine contains several parts: an infinitely long tape that's split into cells containing symbols. There's also a head that can read and write symbols to the tape, a state register that stores the state of the head, and a list of possible instructions. In today's computers, the tape is like the working memory or RAM, the head is the central processing unit, and the list of instructions is held in the computer's memory. Even though a Turing machine is a simple set of rules, it's incredibly powerful, and this is essentially what all computers do nowadays. Although our computers obviously have a few more parts, like permanent storage and all the other components. Every problem that's computable by a Turing machine is computable using lambda calculus, which is the basis of research in programming languages. Computability theory attempts to classify what is and isn't computable. There are some problems that, due to their very nature, can never be solved by a computer. A famous example is the halting problem, where you try and predict whether a program will stop running or carry on forever. There are programs where this is impossible to answer by a computer or a human. Many problems are theoretically solvable, but in practice take too much memory or more steps than the lifetime of the universe to solve, and computational complexity attempts to categorize these problems according to how they scale. There are many different classes of complexity and many classes of problem that fall into each type. There are a lot of real-world problems that fall into these impossible-to-solve categories, but fortunately computer scientists have a bunch of sneaky tricks where you can fudge things and get pretty good answers, but you'll never know if they're the best answer. An algorithm is a set of instructions independent of the hardware or programming language, designed to solve a particular problem. It's kind of like a recipe of how to build a program, and a lot of work is put into developing algorithms to get the best out of computers. Different algorithms can get to the same final result, like sorting a random set of numbers into order, but some algorithms are much more efficient than others. This is studied in algorithmic complexity. Information theory studies the properties of information and how it can be measured, stored, and communicated. One application of this is how well you can compress data, making it take up less memory while preserving all or most of the information. But there are lots of other applications. Related to information theory is coding theory. And cryptography is obviously very important for keeping information sent over the internet secret. There are many different encryption schemes which scramble data and usually rely on some very complex mathematical problem to keep the information locked up. These are the main branches of theoretical computer science, although there are many more that I didn't have time to go into, like logic, graph theory, computational geometry, automata theory, quantum computation, parallel programming, formal methods, and data structures. But let's move on to computer engineering. Designing computers is a challenge because they have to do so many different things. Designers need to try and make sure that they're capable of solving many different kinds of problems as optimally as possible. Every single task that runs on a computer goes through the core of the computer, the CPU. When you're doing lots of different things at the same time, the CPU needs to switch back and forth between these jobs to make sure everything gets done in a reasonable time. This is controlled by a scheduler, which chooses what to do and when and tries to get through the tasks in the most efficient way, which can be a very difficult problem. Multiprocessing helps speed things up because the CPU has several cores that can execute multiple jobs in parallel, but this makes the job of the scheduler even more complex. Computer architecture is how a processor is designed to perform tasks, and different architectures are good at different things. CPUs are general purpose, GPUs are optimized for graphics, and FPGAs can be programmed to be very fast at a very narrow range of tasks. On top of the raw hardware, there are many layers of software written by programmers using many different programming languages. A programming language is how humans tell a computer what to do, and they vary greatly depending on the job at hand, from low-level languages like assembly through to high-level languages like Python or JavaScript for coding websites and apps. In general, the closer a language is to the hardware, the more difficult it is for humans to use. At all stages of this hierarchy, the code that programmers write needs to be turned into raw CPU instructions, and this is done by one or several programs called compilers. Designing programming languages and compilers is a big deal because they are the tool that software engineers use to make everything, so they need to be as easy to use as possible, but also versatile enough to allow programmers to build their crazy ideas. The operating system is the most important piece of software on the computer, as it's what we interact with, and it controls how all of the other programs are run on the hardware, and engineering a good operating system is a huge challenge. This brings us to software engineering, writing bundles of instructions telling the computer what to do. Building good software is an art form because you have to translate your creative ideas into these logical instructions in a specific language, make it as efficient as possible to run, and as free of errors as you can. So there are many best practices and design philosophies that people follow. Some other important areas are getting many computers to communicate and work together to solve problems, storing and retrieving large amounts of data, determining how well computer systems are performing at specific tasks, and creating highly detailed and realistic graphics. Now we get to a really cool part of computer science, getting computers to solve real-world problems. These technologies underlie a lot of the programs, apps, and websites we use. When you're going on vacation and you want to get the best trip for the money, you're solving an optimization problem. Optimization problems appear everywhere, and finding the best path or most efficient combination of parts can save businesses millions of dollars. This is related to Boolean satisfiability, where you attempt to work out if a logic formula can be satisfied or not. This was the first problem proved to be NP complete and so widely considered to be impossible to solve, but amazing development of new SAT solvers means that huge SAT problems are solved routinely today, especially in artificial intelligence. Computers extend our brains and multiply our cognitive abilities. The forefront of computer science research is developing computer systems that can think for themselves, artificial intelligence. There are many avenues that AI research takes, the most prominent of which is machine learning, which aims to develop algorithms and techniques to enable computers to learn from large amounts of data, and then use what they've learned to do something useful, like make decisions or classify things. And there are many different types of machine learning. Closely related are fields like computer vision, trying to make computers able to see objects and images like we do, which uses image processing techniques. Natural language processing aims to get computers to understand and communicate using human language, or to process large amounts of data in the form of words for analysis. This commonly uses another field called knowledge representation, where data is organized according to their relationships, like words with similar meanings are clustered together. Machine learning algorithms have improved because of the large amount of data we give them. Big data looks at how to manage and analyze large amounts of data and get value from it. And we'll get even more data from the Internet of Things, adding data collection and communications to everyday objects. Hacking is not a traditional academic discipline, but definitely worth mentioning, trying to find weaknesses in computer systems and take advantage of them without being noticed. Computational science uses computers to help answer scientific questions, from fundamental physics to neuroscience, and often makes use of supercomputing, which throws the weight of the world's most powerful computers at very large problems, often in the area of simulation. Then there is human-computer interaction, which looks at how to design computer systems to be easy and intuitive to use, virtual reality, augmented reality, and telepresence, enhancing or replacing our experience of reality. And finally, robotics, which gives computers a physical embodiment, from a Roomba to trying to make intelligent human-like machines. So that is my map of computer science, a field that's still developing as fast as it ever has, despite the fact that the underlying hardware is hitting some hard limits as we struggle to miniaturize transistors anymore. So lots of people are working on other kinds of computers to try and overcome this problem. Computers have had an absolutely huge impact on human society, so it's going to be interesting to see where this technology goes in the next 100 years. Who knows, perhaps one day we'll all be computers. As per usual, if you want to get hold of this map as a poster,
Okay, so that was a good video, very colorful video, which actually shows the entire spectrum of computer science. Okay, let me come back to my slides. Okay, so now I hope you guys have a good idea on what is this concept of computer science. Okay, moving on. So if you look at definitions from many literatures, okay, computer science is actually a study, a field of study of computers and computing, as well as their theoretical and practical application. So it's actually a mix between theory and practical, and applies the principles of mathematics, engineering, and logic to a plethora of functions, includes algorithm. I think you saw this word being mentioned in the video. So algorithm is actually a fancy word for what you understand as a formula. So if you've learned mathematics, definitely you'll be using some formula. But in computer science, we don't call it formula, we call it as algorithm. Okay. Software and hardware development, and also future of computing, we also expand to areas like artificial intelligence, virtual reality, augmented reality, and so on. Okay, so this is the domain of computer science. Okay, and if I can sort of extend that domain a bit, so we also look at technical knowledge. So it gives a lot of merit for technical knowledge, skills and background in the design and organization of computer systems. Okay, so one example is if you look at computer technology, maybe 5 years ago and today, so you notice that today's computers are faster, lighter, and they can do more things than a computer can do 5 years ago. Okay. Evaluation of design paradigms. So a lot of emphasis is also happening on design. So when I say design, it's not hardware design alone. It is also touching on software design. Okay, languages, new languages, programming languages, algorithm refinement and techniques to develop software systems. Okay, whether simple or complex. And one of the new things that computer science offer is new technology exploitation. Okay, people are actually thriving on technology. There's a hunger for new technology. So computer science is the best field to deliver these new technologies. Okay, example, from the movies you watch on your smartphones during your LRT, MRT rides, to the functioning of the entire LRT and MRT system, the use of computer science has become part of our daily lives. Okay, even your favorite apps like Instagram, Foodpanda, or Google Maps requires computer science to exist. So if there's no computer science, these applications would not exist. Okay, yeah, so you can thank computer science for that. Okay, what about other fields? Example, in medicine, we can actually use computerized systems to perform scanning and to read scans and diagnose diseases faster. Okay, so that's very important in the field of medicine. In the field of linguistics, which is the study of languages, using computers for speech recognition, translation, and other tasks. And also in economics and business, for example, using models to predict economic conditions. You know, so it's multidisciplinary. So it doesn't mean that if you study computer science, you're going to work in a software development area or what. You can actually expand to other areas as well. Okay. So undertaking a computer science degree will equip you guys with skills to become a competent software developer and programmer. So software development and programming is the core. So these areas are the core of computer science. Okay. In addition, you will also learn aspects of computing such as web and software development, mobile computing, interface design, and also system administration. So interface design is also an interesting area where we talk about user interface and user experience. Have you guys heard about these terms before? User interface and user experience. Okay, let me pause for a while. Have you guys heard about this? Please type in the chat, yes or no. Okay. So for example, when you buy a new mobile phone, immediately you go and customize the phone, right? So the customization feature is allowed by the UI. You know, you can change position, change the color, change the graphic, all this. Okay, so it's allowed by the UI. Okay, yeah. All right, let's continue. Okay, in the video just now, they were talking about a lot of things, but I can summarize here the main subject area of computer science. First, we have to understand the computer theory, which is the theoretical aspect of computers. So stuff like history of computers, computer technology, computer generation, and so on. Okay. Yeah, I know it sounds boring, right? History is always like that, but we have no choice but to look at this. Okay. Programming, of course. Okay. Some people call this as coding. Coding has changed throughout the years, and it's easier to do coding now compared to when I was doing coding. So when I was doing coding, there was no tools only. I was only given a notepad. That's all. You know, like a white paper like that. Okay, start coding. Now we got a lot of tools and technologies and support. So you need not worry about programming or coding nowadays. Okay. Data structures. Okay, since we talk about computer science, one of the things is data. So I think that in the video just now you saw talking about ones and zeros. So this is actually data. And we also need to structure data properly so that we can perform grouping and use it correctly. Okay. Networking, of course, I won't be able to talk to you guys without networking applications. Okay, so networking is very important. Maps will not work without networking and so on. Okay, computer systems as a whole. So we got small computer system, we got large computer systems with multiple applications. So we also need to learn something on this. Languages, this is related to programming. Okay, so it's also study of different languages and what's the difference between different type of languages. So we got high level languages and low level languages. What's the difference? The low level languages are languages closer to the machine. I think in the video you also heard saying machine language. So it's closer to the machine. High level languages are closer to the humans. So if given a choice, I would like to learn a high level language if given a choice. Okay. Of course, some knowledge in mathematics is important as well. Okay, more areas coming up. System analysis and design. Normally we shorten this to SAT. Okay, so I hope you're not sad after listening to this. Okay, but yeah, this is the usual acronym. Okay, so here the focus is on design and modeling. Okay, so it's a process-based subject. Image processing, I think you saw this in the video as well. So this is image recognition, you know, like face recognition. So we can write a program to recognize your face to open the door. So you don't have to use your hand or something. Okay. Digital thinking and innovation. So the future is digital. So it requires an understanding of the digital domain. Okay. If it is not digital, the other domain is called analog. Okay. Operating systems and computer architecture, normally this is together. So this is talking about the main software in computers systems, which is the OS. Okay, like Windows 11, Mac OS, Android, all this. Okay, and computer architecture is the what you call bricks. Okay, that build your computer systems from scratch. All right. System administration, some of you may want to be administrator That means you look at the overall systems in companies and all that. So we'll also explore a bit on that aspect as well. And not forgetting databases, which is basically a collection of data. Okay. Yeah, so this is the main subject area that you would study if you undertake a computer science program. Okay. So the next question is, okay, after seeing all this, right, should I study computer science? Is it the correct course for me? Is it right for me? So a quick way of checking is based on these questions here. Do you value logic and order? Okay, do you always pay attention to logic? What is logic? Let me ask a question. What is logic? What do you understand by logic? Anybody? Common sense is logic. Is that right? You know, sometimes we always, when we speak with people, right? Yeah, what you say is not logic, lah. Yeah, I can see why you're saying common sense, lah. Okay. So you need to explain your reason. Can you explain why you prefer KFC than McDonald's? You cannot say because KFC near my house. So is that answer logical or not? Yeah. Is it logical? Guys? Yes or no? Logical. Logical probably in a sense of saving money or saving time, lah. Okay, but if you look at the values of logic to you, where you are a person who prefer the taste of the chicken, then you say probably neither of them. Okay, just kidding, lah. Okay, so logic is actually how strong you believe in reasoning. You know, challenge. Do you like challenges? You know, do you like to climb Mount Kinabalu? You know, do you like to do that? Okay, yes or no? Or you don't like to take challenges? Okay. Enjoy solving mathematical question. Okay, don't be alarmed by the word mathematics here. So we are not going to go to high level maths, but mathematics is the foundation of all this, lah. Okay, so it's more of a foundation kind of level. And mathematics is actually a mix of logic as well. Okay, so if you've done mathematics, you know, sometimes you have a question, proof A plus B equals to C plus D. Okay, I left maths long time ago, lah. I think these questions are still there. Yes, yeah, correct or wrong? Yes, no? Correct. Okay. So to answer this question, mathematics alone is not enough. So you need to apply logic as well. Yeah, something like this, lah. Okay. Yeah. Like tinkering with gadgets and devices. Okay, now this is a new generation where everybody is having some kind of gadgets with you, correct? So do you love exploring them, you know, doing something with them, trying new things? So if you're somebody like that, computer science is suitable for you, where you got a lot of things to tinker. Okay. Have a knack of computer programming languages. Okay, the computer languages is actually bridging a connection between humans and computers. Because humans don't speak computer language and computers don't speak human language. So we need a bridge which connects humans with computers. That's why you got a field called HCI just now, human computer interaction. Okay. Think you can work independently. Okay, this is not suitable for people who like to work in teams, although sometimes you divide the work, but you also need some skill sets to do things independently. Okay, if you want to value your ideas and your input. And the last point, have some creativity in problem solving. Okay, so how creative is your problem solving approach? All right, so if you say yes, yes, yes to all this question, computer science is right for you. Okay, how many questions is this? There's 1, 2, 3, 4, 5, 6, 7. So if we have 5 out of 7, also it's good enough already. Okay. Okay, coming to the job and career section. All right, so I've now studied computer science. What are my options for work and career? Okay, all right. Again, a long list here. So these are a couple of career prospects that you guys can undertake after going through the study of computer science. You can be a computer engineer. What does a computer engineer do? Improve ways of current computing technology and look for future technology to improve computers. Okay, that means where do I work? I work in HP, I work in Dell, I work in Intel, you know, all these companies. Systems engineer, okay, this is basically you get employed in any organization which has some kind of computerized system. Okay, example is SAP. Okay, so this is an enterprise wide application. Definitely you need some engineers to look at this. Software developer is a very common job. Okay, also called software engineer. Right, so your work is to write software based on clients' requirements. So when I say software, it can be for any domain: medical software, business software, economic software, even games is considered a software. Although we call it games, but underneath it is all programming. Okay, yeah, programmer. All right. And I think if you do well in all this, sooner or later you can be promoted to somebody called a CTO, which is the equivalent to CEO. Means CEO take care of the entire one, CTO takes care of the technology side. Okay. Technical manager. Okay, again, this is more of a management role. Technical architect. So architect is in charge of building and expanding new systems. Okay. And technical support manager. This is in the area of technical manager. Okay. So if the staff doesn't know how to do something, the technical manager can give support, okay, to the staff. Okay. Of course, these are all after a few years lah. You cannot immediately be applying for a CTO job, right? Okay, there's more. IT service desk manager. Okay, this probably you guys have heard this as a help desk. So this is in the area of customer service, where whenever you call a company to report something, let's say I'm calling Unify to say that my Unify is having some problems. So the guy who picks up the call is the service desk staff, and then he reports the issue to the manager. Okay, and they collectively come in to solve your issue. All right, so that's in Unify. You may have these people in HP or whatever company. Application engineer. Okay, again related to the type of application that is used. Okay, then we have server development, server application developer and client application developer. Okay, so this is one guy is looking at the client side of things, another guy is looking at the server side of things. Okay, so this is the architecture part. That means when I use, for example, I use Facebook, my role is the client. So when Facebook supports my requests, so the server is actually handling all my requests. All right. So the server must be able to handle multiple client requests. Okay, so that's why it's not the same, it's separated. Okay. Software architect, this is again tied up with this one. Okay. Software QA, you can also be a QA person if you are into QA. Data warehouse manager, so this is on the database side. And applications architect. Okay, so this is all interrelated lah. Okay, so we call it architect. All right. So these career options are not limited to this list. We also have new career options coming out. I think the other day I saw a career called a UI specialist or something, UI UX specialist. Okay, so we also have new careers coming up as we speak. Okay, next, jobs and salary. Okay, let's say I take up your advice and I apply for this job. What would be my salary like? Okay, this is some reports coming up from Job Street. So if you see, this is I just screen captured just now. So we have 5,399 jobs available in Malaysia and Singapore, I think, in April. This is for April, you know. And you see the first one is the salary offered is software engineer, SGD 3.5K to 7K monthly. Minimum requirement to join this is 2 years experience. Okay, then you see this report. Job demand and salary in Malaysia for computer science is high. Therefore, you can save and invest more money. Okay, so this is written by Eduspiral Consultant Services. Not too long ago. I think it's about 2 years ago. Okay, so I can share a full list of what do you call jobs. Let me click on this. Can you guys see the screen?
Looking at your slide, so I think you may have to reshare.
Okay.
It's a different.
All right, let me reshare that. Yeah. Okay. This one. Okay. Now can, right?
Yep.
Okay. So you see the designation that is popular in the job market is software engineer. Okay. But this software engineer in this company may be doing different things than this software engineer in this company, right? Okay, this is KL. So you see they actually specify particular technologies. So they're not just saying software engineer, they're saying particular technologies. This is actually based on JavaScript. I'm not sure you guys know what is JavaScript. So this is based on JavaScript. JS is JavaScript. Okay, and many others. This one you guys can check if you go to Job Street. Job Street is one of the popular job applications in Malaysia. If you go there to look for job. Okay, so like I said, now it's higher already. See, just now, it was 5.3 something, now it's 5.4 already. Wow. Okay. So there is definitely a market for computer science. Let me get back to my slides. Okay. Okay, so that is actually the end of my short presentation on the field of computer science and job and career prospects. Okay, so anybody have any questions, please feel free to type in the chat.
Right, thanks, Mr. Naresh. Students, if you have any questions, feel free to type it in the chat, or if you want to, on your mic and voice out, that's fine as well.
Yeah, you can speak.
Yep.
Yeah.
It's one question now. Okay, it's by a student. He, I think, private messaged me, so I wouldn't mention his name. So he says that if I didn't take any course about computer science before, I'm interested in how machines in semiconductor works. Should I study computer science or should I go to physics?
Semiconductor. Okay, semiconductor is actually used in computer architecture. So I wouldn't say physics. I would still say computer science.
Okay. There's another question by Hook. I heard there is code interview before you get a job. Is it easy to pass?
Okay, this is a question where before you do the interview or the exam, as per se for coding, I think the employer will inform you, because a lot of people say they know this language, they know that language, and then once they go to work, they start Googling and all that. So I think the companies are aware of all this. So they actually give you a short test. I mean, it won't be a difficult test. It's probably testing you the basics of programming. Should be easy to pass. Yep. Otherwise, we won't be having so many software engineers graduated from APU. Correct or not? Okay, Hook.
All right, guys, keep the question coming. I have a question on my side. So I think from your video earlier, I think computers were invented around 1960s, 50s, 60s, right? So I think in 50, 60 years, we have come a very long way. Right now we have like AI, machine learning, big data and things like that. So would you say that, computer science has peaked, or, where do we go from here? What are computer scientists, up to nowadays?
Okay. Yeah, throughout the ages, computer technology has changed rapidly. Even I think everyone here is changing their mobile phones once a year and changing their laptops once in 2 years. So that shows that people are actually investing in technology because it helps them in their daily routines to be more productive and so on. So I don't think this trend is going to end, and it's not exactly peaking. We are actually exploring new things. As I mentioned in my briefing just now, we are also talking about AI. We are talking about VR, virtual reality. We are also talking about robotics. So we are also exploring the area of integrating all this. There's also development going up on smart homes, smart cars. I think you've heard about the self-driving car, smart homes where you just clap your hand and light turns on, these kind of things. Okay, so it's all becoming integrated. Okay, so people are still hungry for technologies, and this is the driver for computer science and related programs at the moment.
Another private question is that if I study computer science, will I be able to develop, in the field of metaverse? I think metaverse is something we've been hearing a lot recently.
Metaverse is the latest thing that we talk about lately. The concept of metaverse is something like you have existence in a different application as well. It's like if you guys have watched the Avatar movie by James Cameron. Have you guys watched that one? The blue color people, Avatar. So if you remember the main character, he cannot walk, isn't it? He's on a wheelchair, isn't it? Then he goes and wears something, then he's in another world. Then he can jump and run and all that. So that's exactly the multiverse concept. It's something like creating avatars of yourself so that you can engage in multidisciplinary activities at the same time. Okay, so the concept is new, but it's been there for some time. People are not exploring that yet. Okay, yeah, I think that's the multiverse concept. I think another reference is the Doctor Strange movie, Multiverse of Madness, where you open up different dimensions. Yeah, it's something like that. Okay, but to make it, this is still in the concept level. To make it a reality, we are still working hard on the technologies. Okay. Quickly, let me respond to Esri. Okay, the tests they can have different kind of tests. For example, they may not ask you to write coding, but they might ask you to write what we call a pseudocode. A pseudocode is like an algorithm. That means they want to test whether your flow or your structure is correct or not. Yeah, so they might ask you to do that. Correct, Esri. Okay. Yeah. Most CS career work from home nowadays. I guess so, because this is one of the careers that allows you to work from home. Because if you are a doctor or if you are an engineer, you have to go out to the field, isn't it? You have to go to the hospital or clinic to work. But if you're working on a software, you can still work from home. All right, so there is an option to do that. All right, so I think after the pandemic period, a lot of people are rethinking their priorities. Last time when you talk to students, oh, I want to be a doctor, I want to be a lawyer, I want to be an engineer. Then when they see doctors being the frontliners and all that, then they start reconsidering, oh, I think I better be a teacher. Okay, yeah, Hook, right?
Yeah, I just want to add a bit on your comment. So since we cannot work from home, right? It's getting more and more common whereby programmers or web developers, they are able to work from home, for a foreign country. So for example, you can be based in Malaysia, you can work for, let's say, Australian company, a European company and whatnot. And the good news is you will be paid, based on their remuneration on that side of things. So you will be paid in Malaysia ringgit. Yeah, I think that's worth mentioning.
Yeah, also it's worth examining your job contract. So all this will be stated in the job contract. What is your basic salary? Is there any additional perks and all that? Yeah, correct what you said. The world is becoming smaller, so you may end up working with people across the world, Australians, South Americans, or whatever. Okay, yeah, that's another benefit of working from home, made possible by the development of networks. All right. Okay, Wei Ming, is there a big difference between applied maths with computing and CS? Okay, like I said, maths is the foundation. So if you don't pass your maths in foundation level, you cannot proceed already because it is a requirement. Okay, so if you talk about engineering courses, if you want to become a physicist, computer science, or statistician, a mathematician, mathematics is a basic. You have to clear maths first. Okay, yeah. Okay, Wei Ming?
Can I say that mathematics is more of like an indication, on how logical we can be. Because I think like in actual programming, there isn't much mathematics or much formulas, right?
Mathematics is actually building your logic skill. So we need that in the beginning. Because for example, 3 persons are writing a program, person A, person B, person C. Person C is very good in maths, person A and B is not so good. So when we look at the logic and sequencing and all that, we notice that the coding structure of person C is better than person A and B, thanks to mathematics. So it's actually related to problem solving and decision making.
Yep. There's another great question from Hook. Would you like to address that, Mr. Naresh?
Yeah. Programming languages are constantly evolving and upgrading. Okay, wait. How can you keep up with learning multiple languages? Okay. As I mentioned just now, what we are learning now, the programming languages coming out today is supposed to make things easier for you. When I say easier, it's easier because they have a big library. Imagine you study in a school with a small library, then your friend is studying in a school with a bigger library. So who has a better advantage, you or your friend?
The one with the bigger library.
Definitely, definitely. Okay, because you got more resources coming in for you. Last time when I studied programming, let's say for example, I need to insert a button in the program. I need to write a long code just to insert the button. Now you just drag the button only. Okay, so you can imagine. Okay. Yeah, programming languages also got a history of programming languages, like that you rightfully said, C. So that is the C generation. So we start with C, then we got C++, now we got C#. In the future, I don't know, we may have something, CCC or something. Okay, yeah.
Stack Overflow came out.
Yeah. Yeah, right. Stack Overflow is again a resource. So we got a lot of resource around us as well. Okay, so no worries. Okay, so don't be afraid of programming. It's no longer a scary word.
I think
20 years ago,
yeah. For those who don't know what is Stack Overflow, it's basically like a place where you can search for coding problems and solutions, where you can discuss it on it, like with other developers and such. Yeah, so it's like Google for programmers.
Yeah, correct.
Yeah, it is a website. So, you can just Google for Stack Overflow. Yeah.
So if you are going into this area, so you'll be familiar with Stack Overflow, GitHub, and all these things. So they're all interrelated.
Yep. I guess I also want to add a bit on Hook's question. So I think that let's say specifically for high-level languages, say JavaScript, Python or Ruby. So I think once you have picked up at least one of it, the others isn't that much different in the sense of its logic. It's just that the syntax is structured differently. So I think don't worry too much about, there's so much languages out there, but the concept is roughly the same. Yeah. So once you pick one up, it's very easy to pick another language up. Yeah, it's sort of like driving a car. So once you learn how to drive a car, you can drive, many types of cars. It's just the same concept. Yeah.
Yeah, you can drive a van as well and so on.
Yeah,
correct.
Okay.
It's like we are all Malaysians. We speak Bahasa Malaysia. Let's say suddenly I send all of you to Indonesia. They speak Bahasa Indonesia, which is something like Bahasa Malaysia. So you still can communicate, isn't it? It's not that you're totally lost. Correct? Okay.
All right. There's another question from a direct message. What is easy coding language for a beginner to pick up? What would your advice be, Mr. Naresh?
Okay. In my experience, the easiest coding or programming language to pick up is Visual Basic. But nowadays, I see there's not much demand for Visual Basic, and everyone is talking about the Snake. Yeah, so I would suggest the Snake as your first programming languages. I think you know which Snake I'm talking about, lah.
Yeah. Yeah, I think Python is the hype now because it's more efficient in terms of machine learning. I'm not sure if I'm correct in this sense.
Okay. If we start comparing programming languages, we talk about a couple of things like libraries, and we also talk about the coding efficiency. Let's say in Python, I can finish this code in 50 lines, and in C# it takes 70 lines. So we say that, okay, Python is more efficient in that sense. So we have a few other factors to indicate why Python is recommended, okay, over others.
There's a question by Jen Sin. What is the difference between IT and computer science?
Okay, good question. So in my understanding, so how I would put it is that IT is a more lighter version of computer science. Okay, so if you graduate in IT, you are good enough to actually work on applications, which is popularly used by most organizations. But let's say somebody say, what's your name again?
Jenzin.
Jenzin, can you modify my Microsoft Word so that I can sort of write using my pen? Then Jenzin will say, I don't think I know how to do that. I need to call my friend who is a computer science graduate. Okay. But anything else regarding Microsoft Word, Jenzin is an expert. Okay. So that would be the difference between the study of IT and computer science. Okay.
Cool. Guys, I think we have time for maybe one more question. So if you do have it, please raise your hand and ask a question. I think it's quite interesting that students nowadays know things like Stack Overflow, GitHub, and all these things while they're still in school.
Because I think the schools are already starting to teach all this. I think they're already teaching the pseudocodes, flowchart, and all in school already. So it's good. I think it's part of the STEM education.
Oh, there's a question by Fernandez. If we are into this field, what is the main thing that needs to be done now?
Study.
Fernandez, do you want to elaborate a bit more on this question? I think it's quite open-ended.
Okay, I think I understand what he's saying.
Okay.
All right. In this field, to thrive in this field, to be better than everyone else, there's two things. One is on the academic qualification. The other one is on the technical qualification. Okay. So although you have an academic degree, you need to top it up with some example like Microsoft certified something, Cisco certified something. The latest one is AWS certified, which is Amazon Web Services. I don't know if you guys heard about this or not. So this certification will give an added advantage on top of your academic degree. So it depends on your interest. Let's say you are interested in networking, then you probably want to do a Cisco certified something, CCNA or Cisco certified network administrator or something like that. Last time, the most popular certification was Microsoft. We also have in multimedia, if you want to do Adobe certified something, we also have it. So there's many certifications out there. And these certifications will give you an added advantage okay, if you are entering the field. Okay, Fernandez?
Yeah, I think most of these certifications, we have to pay for it. Is it free to take the exam?
Okay, some institution embed the certification into your program. Some you have to do it like a part-time kind of thing. So depends on you actually, and depends on the institution.
Okay, cool. I think we had quite a number of good questions today. I think we are about to wrap things up. So maybe can either Mr. Naresh or Ms. Miat tell us more about the entry requirements to computer science and APU?
Okay, I think that one
sure.
I'll leave it to Miat lah.
Yep.
Okay.
Thank you, Mr. Naresh.
Thank you.
Okay, hi everyone. If let's say for the computer science requirement, basically we'll have to start from pre-U. So pre-U, basically we have a foundation or diploma. Okay, but I think we're short of time, right? But I'll just quickly let everyone know that for pre-U, for foundation, we have foundation in computing and technology. The requirement will be 5 credits, including maths, past PM Sejarah. Okay, it's not required you to have maths. Oh, okay. Yeah, it's not required you to have maths, but if you have it, then it will be beneficial. Okay, so for diploma, the requirement will be 3 credits, including maths, past PM Sejarah. Okay, so for the diploma, basically we have 4 types. If you want to lead to our computer science. So basically we have a diploma in ICT specialized in software engineering. And another one, it will be specialized in data informatics. Okay, so of course, for any information, you can always refer to Edumetry. So they will provide you the information. Okay, so of course, if let's say for SPM levels, we're offering scholarships as well, which is a very motivate things that for students. So we have a scholarship as long as you have 4 A's and above. We provide start from 10%. Okay, but if Leon, we have some time, I can share some screen. Is it all right? Okay. Of course, for computer science or IT or software engineering programs, it required mathematics. Okay, so scholarships information, basically, of course, you can refer back to Edumetry, but here a very quick share about our scholarships information. We can see that for our SPM, we will require 4 to 5 A's, including A-. Okay, we provide 10% discount, 6 A's 20%, 7 A's 30, 8 A's 40, and 9 A's 50. So I believe here we have any from 4 or from 5 students. So this one will be another motivation for you to study hard. And if let's say for SPM or STPM levers, this is for the SPM qualification. And first come, first serve for our scholarship. If let's say for STPM, we are looking at the best 3 subjects, which is a 3.7 and above, CGPA 3.7 and above, we'll provide 50%. If let's say for 3.4, 35, 3.0, 20%, we were looking at the best 3 subjects. Okay, so for our scholarships is applicable if let's say you start from our pre-U, the scholarship will be applicable from pre-U until degree. Okay, so same goes to STPM. As long you maintain the CGPA, we will provide your scholarship for another 3 years. Okay. Yeah, thank you for the sharing, Leon. So you can refer to the link for our Asia Pacific University courses. Okay, so mainly if you want to go for computer science related programs, just now mentioned, just a reminder, maths is very important. At least 5 credits and above, pass PM Sejarah. And another important subject, it will be English. Okay, so without English, actually students will have to go for an English placement test, which is we are not really encourage you to have it. So as long you pass your English, you are able to enter for the program. Okay, so try your best for all of the subjects. Okay, so if you have any questions, you can leave in the chat box as well. I will quickly answer you. Okay. Any questions?
Yep, students, if you have any questions, feel free to ask now. If you thought of a question after this, you can always look for us on our platform, edumetry.app, to the link, and there is a small WhatsApp button at the corner, which you can use it to contact us directly. All right. Okay, doesn't seem like there's any question at the moment. So I just want to take this opportunity to thank APU. Thank you, Mr. Naresh and Ms. Mia, for taking your time, to share all of these things to the students. I hope that you guys have learned something new as well.